All right, we're in the second part of your review guide. Let me adjust this. There we go. So number 16 asks you to make a table of values. Normally we just have our T table or this, don't mind my lovely nail, where this is where you do your work. Okay, so you're going to put an X value in, complete your work, get a Y value. So I tend to just pick values on the left side of the graph, the center, and the right side. Okay, some positive, negatives, and 0. So when I substitute in a negative value, I'll get a positive 6 plus 3, which is 9. When I substitute in a negative 2, it'll become positive times 2, which is 4, plus 3, which is 7. Substitute in a negative 1 plus 3, that's going to be 5. Put in 0 plus 3, which is 3. Substitute in 1. Okay, it should be symmetrical going back. And I'll have a V shape. So I was allowed to put any number in. So my domain is all real numbers, or you could say X is an element of all the real numbers. And then your range, not everything came out. Let's take a better look. Okay, so we put in negative 3, my output is 9. I put in negative 2, my output is 7. I substituted negative 1 and my output is 5. I substituted in 0, my output is 3. 1, we're going back, it's 5. 2 is 7. Let's make it symmetrical here. So it's going to be that V shape. If you don't see the V shape, you didn't graph it right. This needs adjusted. Okay. So we see here the domain would be all real numbers because these barriers you can break through with the arrows. So it's not restricted. However, though, your lowest value here is 3, and your highest value, you don't ever stop. So your range is Y is greater than or equal to 3. Another way to write this is saying, make it an interval and say 3 to infinity. Either way, I don't care. Okay, I'm just showing you all the types of notations you could see in different textbooks or in college or a different tech class. All right, this next section was part of piecewise functions. They're situational functions. So if your values are from negative 3 to 1, let's put in negative 3 and let's put in 1, and what will we get? If I put in negative 3, I'm going to get negative 1, and if I substitute in 1, I'm going to get 3. So we go to negative 3, and you're going to put in negative 1. I'm leaving this circle open, though, because we don't quite actually get negative 3. It's like negative 2.9999, so it's so close that we're going to use 3, but that's the value. Open circle. We actually do use 1, and we get 1, 2, 3. So I only need 2 points for a line, so I'm going to use the endpoints to make sure all the points are covered. All right, and now here I'm going to make another T table, or an XY table, and I'm going to substitute in 1. I'm going to put 1 in, I'm going to get negative 2. And that's an open circle as well. And then I'm going to substitute a number greater than 1. Let's jump over to like 4. I'm going to put 4 and I'm going to get 1. 1, 2, 3, 4. We get 1. Oh, I can keep going though. So it says graph the following functions, state the domain and the range. Well, the domain was negative 3 to 1, 1 to infinity. So we started here and I have something the rest of the way. So we start at negative 3. So the domain X is greater than negative 3, and the range, our lowest value here was negative 2, and we have something forever. So we're just greater than negative 2. We don't actually equal it. Okay. Up here, did we answer all the questions now that I think about it? We made a table of values, we graphed. Did we state the translation from the parent function? So if the absolute value of X was the parent function, what did the plus 3 do? It raised your graph up 3, and then multiply by 2, made it look up here thinner or stretched. So there was a vertical stretch of 2, and then we went up 3 units. You could say vertical shift of 3 as well. Okay, so the second part is just another type of graph. It's going to have constant functions in it like 4 and -2. So let's make our t-tables. These are actually easier because they're giving you the starting and end points. So we're going to have 3 because we have 3 equations. Okay, if I substitute in -4, I'm just going to get 4. If I substitute in -1, I'm just going to get 4. Let's try it. -4, I get 4. 1, 2, 3, 4. It's going to be an open circle. And the last value, you're going to use all that up until -1. Okay. All right. The next one, you start from -1 to 2. So let me turn on another light. This is a little dark. Okay. When I substitute in -1, I'm going to get -5. When I substitute in +2, I'm going to get +1. So let's go over to -1. I'm going to get 1, 2, 3, 4, 5. It's going to be an open circle because I'm not equal to. Let's start with 2, substitute in, and I got 1. So 1, 2. Okay. All right, here, start at 2, you get -2. And a number greater than 2, let's do 4. So I'm going to go 1, 2, I get -2. I put in 4, 1, 2, 3, 4, I get -2. And we can keep going. Sometimes just remember you have the arrow. Okay, so that's your function. It asks for the domain. Your domain is -4 to 1, -1, all the way to 2, and 2 greater. So we start at -4, and we have something continuing. So our domain is x is greater than -4. Our range is 1, 2, 3, 4, 5, -5. So we start at -5, and we have something all the way to 1. Okay, comma, also 4. Then we have 3 piecewise functions that we have to write now. So some students can't see this, but there's an arrow here, and there's an arrow here. So that's 1, 2, 3 functions. So this one is just a -2. But from what to what? Well, we're starting at -4, and we keep getting something. So when x is less than -4, okay, that's when there's something. Then from -4 to +2, we are up 1 over 2, up 1 over 2. Your y-intercept is 0. Now, do you have to put +0? No. If you want to, that's fine by me. I don't know if that'll be okay in your other math classes. But for me, it's fine, but it helps you. Here's the thing. We can't tell which one's filled in. So as long as you make one filled in and not the other, you'll still get the same result. If I put -4 in here, I get -2. If I put -4 in here, I get -2. So pick either one. Why we can't pick both is if you were to type this in a computer, the computer would error and say, I don't know which equation you want me to go to. It wouldn't be a function, okay? Here, same thing with the 2. if you didn't make this one equal, make this one equal. So when x is greater than 2, you are 1. Okay. The next one, you have two equations, 1, 2. So f of x equals. This one, the equation is up 1 over 1, up 1 over 1, up 1 over 1, all the way to 3. Up 1 over 1, all the way to 3. So we start at -3 and we're less than. Okay, if you can't tell, looks equal to, sure, put it. On your test, it'll be very, very vivid if it is equal to or not. Here, same thing, up 1 over 1. Your y-intercept here is 0, so you don't need to put it. X is greater than 0. And lastly, we have two equations here. Some students say that's an equation. I would agree, but I'm not going to use it. Or we can do that. That's fine. Let's do that because some people will have it. They want to know what it is. Like I said, if you have questions in the test for clarity, you can ask, but it will be very clear what you're supposed to do. I just like these three graphs for your review. That's why I use them. Here, you're at 0 for all of them. You start at 0, you start at 0, you start at 0. So we start at 0. So when you're less than 0, when you're equal to 0, and when you're greater than 0 are your three equations. So when you're less than 0, your slope is 1. So you can put 1x if you want. And your y-intercept is -2. Here, when you're greater than 0, your slope is 1 and you're at +2. Here, when you're at 0, your output's 0. Like I said, if you didn't have this, I probably would take that. Okay, but always ask the questions. It will be very clear in your test. Okay, and lastly, on the back, let's start at the bottom because that was the easiest step. That's actually the second day of what you learned. Okay, it says identify each transformation from the parent function x squared to g. So when you're x squared, you're simply just a quadratic. When you multiply by 2, that's a vertical stretch of 2. Like I always said, imagine if I took your height and multiplied it by 2 and your head went up, you'd be very skinny. Okay, you'd be stretched. So it's a vertical stretch of 2. The negative inside is a reflection on the y-axis. Since it's symmetrical, you wouldn't notice. Here, think of these as two separate entities. Same thing, x squared. The 1/2 will not stretch, it'll make it smaller. It'll look fatter, it'll be compressed, vertically compressed by a factor of 1/2. And then that negative will make all that positive outputs flipped over negative, so it'll be a reflection on x-axis. And here, there's going to be reflection on x-axis. The 5 is separate. Think of it as something completely separate. Not a -5, but the 5 is a vertical stretch of 5. Okay. Here now they're giving you the function, or they want you to create the function given the actual transformations. So if I took this and compressed it by a factor of 1/2, and then I translated it up for units, we would call that not f of x anymore. It's a new one, so let's just call it g of x. I don't care what kind of x, but it's not f of x anymore. It's a new function. Here, if I went 7 units down and vertically stretched by a factor of 3, that's what this would look like. Here, we're starting with 3x plus 1. We're not starting with just x. We're starting with 3x plus 1. If I were to reflect across the x-axis, I'm negating the whole thing. So that's why this one's a little bit different, because we're starting with a whole function besides just x. And we're negating the whole thing. Okay. The graph of absolute value of x is vertically stretched by a factor of 5, up 3 units, and then reflected across the x-axis. Let's call it h of x. Sure, why not? Spice it up. Okay. All right, so those are the reflections. Now let's talk about the last unit we had, which was step functions. So we talked about it in class, just actually rounding up or rounding down. So a parking garage. So it's $5 to just go to the parking garage. And then it's $1.25 per hour. Why they have the -1 is because that first hour, they just want you to pay $5. So they want to charge you $1.25 for that hour along with it. So that's where they subtract one. They want to round it up though, because what if you parked for an hour and a half? They're going to charge you for that second hour. They're going to round it though. They're not going to charge you for half of an hour. That's why it has the round up symbol. So you don't really need to know that. You can plug in the numbers, but that I'm explaining it so it makes sense. It says where H is the number of hours you parked and C is the cost in dollars. Find the cost of parking at the garage for 3/4 of an hour, which would be 45 minutes, and for 8.5 hours. So we're putting in 3/4 of an hour. So if I park for 45 minutes, it was going to round that up. So if I remove 3/4 from -1, that's negative 1/4. So when you round that up, it's 0. Did you really park for 0? No, but they're going to charge you. When you round this up, it becomes 0. It's only going to charge you for $5 if you were within that hour. Okay, another one is 8.5 or 8 1/4, which is 8 hours and 15 minutes. So they're only going to charge you for 7 hours and 15 minutes. Well, they're not going to charge you for 7 hours and 15 minutes. They're going to round that up to 8. So $5 an hour plus $1.25 per hour. 8 1/4 minus 1 is 7 1/4. They rounded it up to 8 hours, so you're just paying for 8 hours of parking. So that's going to be $10 plus the $5. So $15 to park for 8 and 1/4 hour. Okay, here we talked about step functions in class, rounding up or rounding down, greatest integer function. Okay. So you're going to see different symbols. It depends on the textbook you have. So I'll show you in ours what it looks like. So here, this is another type of like piecewise function. It says, unlike a piecewise function, a piecewise linear function contains a single expression. A common piecewise function is called a step function. Okay, so it has double bars. I think on your review it's single bars. It just depends on the textbook. The graph of a step function consists of line segments. The greatest integer function is one kind of step function. The symbol here means the greatest integer less than. It's kind of tricky. It's like the greatest integer. So you think rounding up, but it's not. It's less than or equal to x. For example, if you have 3.25, it's 3. If you have negative 4.6, you think, oh, 0.6 round to, no, it rounds down. Okay. So you're rounding down every time. So seeing this is actually rounding down. When would you see rounding up? We showed these. Your textbook doesn't talk about it in this textbook, but the old Honors Algebra 2 textbook did. We talked about that in class. So here, let's just take a few numbers. Let's pick, let's pick 2.1. You know what? Let's just get rid of this 1 for right now. And let's just talk about the rounding down function. Let's talk about 2.1, 2.4, 2.6, 2.9. What would happen when I put those in? So if I put 2.1 in, that's going to round down to 2. Okay, so if you go to 2.1, it's going to round down to 2. Okay, when you go to 2.4, that's going to round down to 2. When you go to 2.6, that's going to round down to 2. When you have 2.9, that's going to round down to 2. 3 is not going to round down to 2. So when you hit the number 3, it's an open circle. So what if I put in the number 2? That will stay at 2. So really, this is a horrible graph for graphing this. And I'm not going to make you on your test. I just want you to have practice with it. Whatever number you start out with, that's the dot. And then you go across to get to the next number, and it's an open circle because you won't touch that number. So the next, if I put in 3, you go to 3, fill it in to here. You go to 4, fill it in to here. And you can't see as well, but then it'll start looking like this. You know? So if I had 2 like I had, 2, fill it in, open circle. 3, fill it in, open circle. Okay, and it looks like steps because it's rounding up or rounding down. Well, it's going to be these little constant functions because you're not going to go to 2.5. You're going to go to a whole number. Okay, so like I said, we're not going to graph them. I just want you to be aware of it and that they exist and that computers use it for all kinds of money managing things. Okay, so if you graph it, great. If you don't, fine. So on this review, I need everything done perfectly. I would like you to attempt this. But if you do not fill out every single problem, that is considered not completing the review. Okay, that is the end of part 2. If you have any questions, please email me.